Hello，嗨
Hi，老师。
，Hello teacher，
你好，老师。
声音咋那么大啊？你好， Hi.
Okay, now we will sign in, and I will show the codes, and you scan the codes and sign in. Okay, here. Huh? Okay.
We scan it with WeChat.
Wait a moment. Here, please. You, both of you, scan this. Yeah, to sign in. Yeah, waiting. Yeah, yeah. You should log in. This is your account, my account, your passport number. Yeah, and uh, no passport number and do you remember your 密码? Yeah, you know. Yeah, this login. No. Wait a moment. Here.
Now she
Wait
check
a minute.
the WeChat convert. It's not working.
This is the HUB. And now maybe I sent to our WeChat group. Why the belt? Oh,
Not working.
okay. Okay, maybe this is. I think this is really. So maybe I think this is not a choice to scan this code to sign in. Now I will also call everyone's ID and one by one. Okay, we use the old method to. Okay. Okay, don't worry. Now I will call your ID and you just send you are here or just answer to me. Okay. What's wrong? No, one by one. Okay, you can say your ID here. No. Yeah, also one. No worry. 侯赛哲, the first one is 侯赛哲.
I'm present, 老师.
Hello, 侯赛哲, are you here? Okay, now you can say this is present.
Can't you hear me,
The
Lausi?
second one, your R. The second one. Hello, this one. Also,
Present, Lavshi.
it's your turn, okay? It's just the second one. Your R.
Present, Lavshi.
Yes, I can't hear you. Why? Why? Hello? Huh? Why I can't hear you? Neil, internet problem. No clue. It's this I mute everyone. Yeah, now okay, I will. Okay, wait a moment. I will try it again and. Eh? 我听不到啊。
Teacher, I am here. 205. I'm here.
Okay, wait for where I will find why I can you. Now,
Hello.
Hello,
Can you hear?
Hello.
hello, Lausi.
Hello, Lavshi. Hello.
Hello, mic testing. Hello.
Hello.
Hello, teacher.
yeah, but I can't hear. I can't hear.
Сука, бля.
这为啥呀？看见声音跟到最小了吗？
صعب تقولي شعر معروسي.
بيدرس روسكي. شاعر
حمزة فاشيلي يقولوا
ارخص شكون معروف
حمزة فاشيلك.
Hello.
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 Lausi.
لو
Oh.
صمك
Lausi.
Русский пидорас. Слава.
Slava Ukraine.
Yes.
Laushi, where are you? We can hear you clearly as well.
Slava русский.
205 teacher, I am here.
Laushi, are you still there?
صعبات سي اس درس خدمت.
Hi.
Hello, teacher. How are you doing?
تقول لا راه كنت تعارف.
شو واحد عنده الايكو.
شكون هذا؟
سكان في الطياب.
Hello.
Hello.
Laushi, we are hearing you.
Hello Laushi.
واحد تيقد ليا انا.
Hi.
Hello.
Okay.
يمكن لي الريكورد هذا.
Okay. The second one. This one. Your Hello.
Hello, Laushi, I'm here. 25MD 09.
She can't hear. She can't hear you. Baby.
Okay, I can hear you. The third one.
أمير مس أمير.
Mimi.
أمير.
The one. 高三1213
Present teacher. Present teacher.
1209
Present teacher. Yeah, Laushi, I'm here.
可贝特
Present teacher.
I'm present.
Oh my.
可贝特
I'm present.
I'm present.
6207 6207 Okay, yes. 1213 6207Hello. 1220。1206。
Teacher, I'm here.
OK。1210。
I'm present, teacher.
OK。1204。
Present. I'm here, miss.
1205。
Present,老师。
1203。
Present, teacher. Present.
6212。
I'm here, miss.
This one. Yeah. 欧舒文。
Here, I am here, teacher. I'm here. 205 here.
蕾蕾。OK。艾莫斯。1216。
Present, miss. Present.
1215。
I'm here, miss.
1202。6208。6208。6209。
Hello, Laushi. Can you hearing me?
Yeah, I can hear you.
Teacher,
yeah.
I completed. Teacher.
1212。
Teacher, I'm present.
What's your ID? OK。于连。OK, now I check it.
Teacher, I complete my tuition fee, but I don't see my name on present book. Teacher, my student is 211576210.
This means you did say your ID here.
No, teacher,
Okay.
my student is not here.
No, your ID. OK.
211576210.
OK. Which one? 21202。
Yes, teacher.
Which one? 1 is missing. 12。Wait, now I check it. 6207。
Teacher, what are you doing now?
Yes, I went to the international education, and maybe we'll write your ID tomorrow. Okay. Now I check the
Okay.
absent. 6207。
Teacher, I will message you in your WeChat inbox. Please check it, Laushi,
Do you have
after class.
the tuition? 6210。 傅恒。6207。 1220。 Which one? Which one? Which one? Yes, I write your ID 12115515211155211555211. Yes, I write your ID. We have two students. I will choose the School of International Education, and maybe they will write your ID. Okay, tomorrow. Tomorrow they will write your ID. Now I receive. And no worry, okay. I received two students. The first one is 2111555220，2115512，2115512，and the second one is 付恒，2111576。
Yes, teacher, Fu Hang.
210. Okay,
My Chinese name
these
is Fu
two
Hang.
students, yeah, maybe we'll add your ID. Okay, we will add your ID tomorrow, and I will let you be present. Okay, don't worry about it. Now I check it. 120 is absent, right? Oh, this was. And this one 6208。
So, teacher, today class I will absent, right, teacher?
Yes, you'll be present. Okay. 6209 don't worry about it. 6209 6209 okay. What? Amos, yeah, Amos is. Oh,
Teacher, what about me? You didn't call my name.
老师 miss you.
My Chinese name is Corey.
do you have pay fee? 你付费了吗？Which one is not here? Please send your ID now. Which one is not? Maybe you think your ID. Which one? Your ID is not included. Which one? Except this one. Except you need a Chinese name. You should. You think about it. Okay. This is just the. 你付学费了吗？交费了吗？学费这样写吧。You have pay your tuition 6209 your ID is not included. Correct. 6204 Okay. Okay, I will report it to the School of International Education. Okay, and I think they will add your ID maybe tonight, maybe tomorrow. Okay, don't worry about it because we begin to our class about 30 minutes past. Okay, we begin our class now. So don't worry about it. After class, I will report it to the School of International Education. Okay. Which one? 6209. Why you are late for a long time? This is your you. Okay, I change it. Please send your ID to our WeChat group if this. Okay. You can choose a Chinese name by yourself. Okay, we begin our class. You can choose a Chinese name by yourself. Okay. Do you know this? Do you know this? I have one. Do you know this? dxx, the power is minus 2 dx, the derivative of this function. Oh, do you remember it? dx, this is x power. Hello? Do you remember this? dx, x power n. What's your result? What's your answer for this one? dx, x power n. This is equal to nx minus 1. Nx is power minus 1. Right? So dx minus 2 is equal to minus 2x minus power 3. Yes, right. And now this is with dx, this x squared over 2 is equal to x. And dxx is x0. x0, this is equal to 1. And we have dx this minus 1, this negative 1 over x is equal to dx negative x power minus 1. So it's equal to a minus negative 1 times negative 1 times x, this is the power negative 2. This. So we have this result is x power minus 2, right? X power minus 2. And we also know dx, this negative x, negative 2 over 2 is equal to x is minus 3, right? Minus 3. But here, this one, we should notice that here this x power 1, x power 0, and x, this power is negative 2, this is negative 3. So we want to know dx, this is which number is equal to, or which function is equal to x negative 1, right? Negative 1. We do not know this function. This means we want to find dx, this which number is, which function is x, the power is negative 1. This means is their function whose derivative is x power 1 is equal to 1 over x. The 1 over x, the upwards is there, and this means we want to find this function. So this means we want to find antiderivative. This one, antiderivative. This is the indefinite degree 1 over x dx. And last semester we have learned the first fundamental theorem of calculus. This means we have a function, this is fx, is ax at t, and the number is dx. If fx is the definite degree of f, the lower limit is a and upper limit is x, you know, dx fx is equal to, do you know this? Is equal to fx. Just change t, this integrand, the variable is t, you just change t inside or replace t by x, ax after dt. So this is a function whose derivative is fx, provides that here f is continuous on an interval I that contains a and x. And in this sense, this means we can find an antiderivative of any continuous function. The existence of an antiderivative does not mean that the antiderivative can be expressed in terms of functions that we have studied so far. In this chapter, we will introduce and study a number of new functions. Okay. Our first new function is choosing to fill the gap. Notice about we call it the natural logarithm function. This one, natural logarithm function, and it does have something to do with logarithm started in algebra, but this relationship will only appear later. And now we will learn. This means we want to find this function dx what is equal to 1 over x. We will give this is a natural logarithm function. We denote it by this new function. We denote it by ln LA. LA is defined by this new function ln x. Just a symbol like we write y is fx. This is ln x. Ln x is equal to this. The lower limit is 1, upper limit is x. The integrand is 1 over t dt. 1 over t dt. Here we notice that x is greater than 0. This means this new function ln x the domain of the natural logarithm is a set of positive numbers. This means we write D, the domain is equal to x is greater than 0. Okay, and then we give the diagrams in figure 1. Here, this is we can draw the graph of the function y is 1 over t. Y is 1 over t, right? Y is 1 over t, and we know this is log x. This is the definite graph. Now we know if we write this is a b fx dx, a b fx dx. This we learn to this definite graph and demonstrate if this is a curve y is fx and interval is ab. And this definite graph, if fx is the positive, so this definite graph is the area of this range. It's the range under y is fx and between x is a and x is b. So here, log x, we know this is just the f, the variable, this is t. So this means ft is 1 over t. And here a is 1 and a is 1 and the b is x. A is 1, b is x. So we have this, if this is 1, this is x is greater than 1. And so we have log x is the area of R. This is y is ft. The curve y is 1 over t. And this is x is 1. This is x. Here is x. So this definite graph is the area of this range R. Do you remember it? Okay. And here this is x is greater than 1. X is greater than 1. And the negative of the area, the graph, you don't understand it? You don't understand how to draw y is 1 over t, or you don't understand why this definite graph is the area of this range. Y is 1 over t. Here, this is integrand is 1 over t. Okay. This integrand is 1 over t. So here, just like this, the integrand is fx. So we give the curve of fx. The upper limit is b, the lower limit is a. So it's between xa and xb. Between xa and xb. And ft is 1 over t. So this is y is 1 over t. You understand it? Okay, and here this is x is greater than 1, so x is in the right 1. And if x is greater than 0, that's 1. So we have this is log x. Log x is equal to, this is from 1 to x 1 over t dt. Here we just have x is between 0 and 1. And maybe we can write, we know the property, we can, if we choose the upper limit and the lower limit is negative x1 1 over t dt. So here this is x. We see this definite graph. Here the lower limit x is less than 1. And so this definitely graph, this definite integral is equal to the area of this reach R. The area of the reach R. And here is a negative. So this is negative. This means log x here is the negative area of R. If x is greater than 0 or less than 1. Okay. And clearly log x is well defined for x is greater than 0. And log x is not defined for x is negative or equal to 0 because this definite integral does not exist over an interval that includes 0. Okay. Here, this is y is 1 over t. This is 0. For example, this is this is 1. And if we write this is x is this if this interval includes 0, this definitely integral does not exist. So we have this function log x. We have this log x. We have the domain is equal to x is greater than 0. This x is greater than 0. Okay, x is greater than 0. X is not equal to 0, and if x is negative, this definite integral is from 1 to x 1 over t dt. This definite integral is also meaningless. So we have this functional domain is x is greater than 0. It's just well defined for x is greater than 0. And by the first fundamental theorem of calculus, we just reviewed this ax ft dt. We have prime. This is the first fundamental theorem. Well, the result is equal to we just replace t by x. This is fx. It's fx. So here, a here this is 1, and upper limit is 0x, but here ft is 1 over t. This is 1 over t dt. So we have the derivative is equal to this. This means this is equal to 1 over x, right? We just replace t by x. We just replace t by x. So this means dx, because this is equal to d log x. So we have the result is d log x is equal to 1 over x. Now this means we find a function. And at the beginning, we want to find dx what is equal to 1 over x, or x power -1, right? But here we find which one? dx, this is log x is equal to 1 over x. 1 over x, this new function, natural logarithm function. We have learned this log x. And this function log x. And now we will use the combined rectangle. Do you remember rectangle? This is by the rectangle we can calculate the derivative or more calculate the more complicated functions. Do you remember rectangle? Hello? Does anyone remember rectangle to calculate the derivative? d dx ln x is 1 over. Do you remember, Chandler? This means if we have a composition, gx is fgx, this is dx. The chain rule is which the decompose this function. Decompose fgx, decompose it as y is fu, y is fu, u is gx, y is fu, u is gx. Decompose y is fu, u is gx. And so we have dx f gx. The result is equal to first calculate the, here this is outer function. Calculate the derivative of the outer function at the inner function. This means it's equal to, we write this dy over du times the derivative of the inner function. This inner function is gx. So times du over dx. So the result is equal to, this is f prime u. F prime u times g prime x. And here we should replace u by gx. So it's equal to f prime gx, g prime x. And here we use this chain rule to calculate example 1. Example 1 here, this is here we have ln dx, ln the square root of x. This is the composition. And we can decompose it. Decompose it as we can decompose it as here we like u is the square root of x. U is the square root of x and y is ln u. Y is ln u. Do you remember it? Decompose it. No? Okay, decompose it and then we calculate and here the inner function is u is the square root of x and the outer function is y is ln u. So we find the dx ln the square root of x is equal to the derivative of the outer function is du square root of outer function ln u. Ln u times the derivative of the inner function. Inner function is dx the square root of x. And we just want du ln u. We have learned dx ln x is 1 over x. So du ln u is 1 over u times dx to the square root of x is equal by the power 0 is equal to 1 over 2x 2. And then we can replace u by the square root of x. So to this one, this one, right? Yes, the answer is 1 over 2x. This one is right. Example 1 and questions. Example 1. No, okay. And example 2, I will explain them together. Okay. This is dx ln x squared minus x minus 2. And we can also decompose this function. It's ln x squared minus x minus 2. Decompose it as y is ln u, and u is x squared minus x minus 2, right? Y is ln u. U is x squared minus x minus 2. So this is a composition, and we will use the channel. We choose the channel first. Find the dx ln x squared minus x minus 2 is equal to the derivative of the the outer function ln u. The derivative is 1 over u. 1 over u times the derivative of the inner function. Here, this is dx x squared minus x minus 2. So it's equal to 1 over, which will replace u by x squared minus x minus 2 times, here we use the power 0. This is equal to 2x minus 1. 2x minus 1. Right? So this is the final answer. This is 2x minus 1 over x squared minus x minus 2. This is example 2. Any questions for this one? No? No? Okay, and example 3. Still. And now I will start example 3. This is dx, this ln the absolute value of x is equal to 1 over x. This x is not 0. And we just learned dx ln x. This x is positive. The result is 1 over x. So we should have 2 cases to be considered. The first one is x is greater than 0. We know the absolute value of x is x, right? And so dx ln the absolute value of x is equal to dx ln x. And we learned this is 1 over x, right? And then if x is negative, no, the absolute value of x is negative x. And then we calculate this dx ln negative x here. This ln negative x, this is also a composition. So we can decompose it. Is y is ln u, u is minus negative x. So the result is 1 over u, u is negative x. So 1 over negative x dx is negative x. And so we found it's 1 over x. And we know that for every differentiation formula, there is a corresponding integrating formula. So from example 3, we have if the derivative of this function is 1 over x. So we have the inverse processes is the indefinite integral is equal to ln the absolute value x plus c x is not 0 or with u replaced by x. We have this. 这张图的 form。OK， 死机了。Hello. Can you hear me? Okay, so we have this.
Yes, yes.
Okay, example 3 and questions for example 3. I think both of you should review. I think both of you should review what I have learned last semester. Because I haven't known the first class is our first class, but I think you don't know anything. You don't know anything. Yeah? No, I just think you should review what I've learned in last semester. Because this is just our first class, that both of you don't understand. Yeah. So, no questions for exam 3, and we will talk about example. Maybe I will give you some questions about how to calculate the indefinite graph. Okay, because I'm afraid you have forgotten this one. Do you know how to? Remember how to calculate the indefinite graph by the substitutor? Remember it? Now, to remember it one. Here, if this is 2x, yeah, okay, this one. Calculate this indefinite graph by the substituent. And this is the first one, review. And the second one, maybe for this one.